Hi all, myself Kartika, and we are going to discuss one interesting topic in chemistry. Right? What is the topic? Quantum numbers. I hope you all know about the types of quantum numbers like principal, azimuthal, magnetic, and spin quantum. First of all, how these quantum numbers are generated, like from where we can get this quantum number in the sense from the Schrodinger wave equation. So from the Schrodinger wave equation, we can get three quantum numbers from the space geometry and the last one from the electron spin. First three, like principal, azimuthal, and magnetic quantum number arises due to the space geometry part, and the next one is from electron spin part, right? Generally, what is a quantum number in the sense? It gives information about the exact location of an electron in an atom. Right? It's like address of a person. Right? Similarly, in an atom, in which shell, in which subshell, in which orbital electron is located. Like that, we can able to say the exact location of an electron using these quantum numbers. So we can say quantum numbers are like a unique code for individual electron present in an atom. So it gives information about the location of electron. Location of an electron in an atom. What are the types? 4 types of quantum numbers are there. What are they? Principal quantum number. Azimuthal quantum number. Magnetic quantum number. And electron spin quantum number. Each has some alphabet for the representation. So first one, principal quantum number represented by the symbol M, and azimuthal quantum number L, magnetic quantum number M, and electron spin quantum number S or ES. Like that we can represent. We are going to discuss one by one what are the use of principal quantum number and different types. First one, principal quantum number. Principal quantum number gives an information about in which shell electron is located. You know very well about the shell numbers, right? What are the shells are there? It gives information about the shells in which electron is present. So the shells are K, L, M, and N. What is the principal quantum number? How can we represent K shell, L shell kind of thing? So the principal quantum number will be 1, 2, 3, 4. And what are the permissible value for this principal quantum number? In the sense, it's all integers, 1 to infinity. We should not give 0 first. So this m value can be 1 to infinity. Right. If n is equal to 1, the electron located in the first shell. If n is equal to 2, the electron located in the second shell. For example, if an electron present like this, 2s1, what is the shell number? It is 2. N is equal to. It's belong to L shell. What are the major application of principal quantum number? Principal quantum number gives information about the size, energy, etc. If n value increases, energy of the orbit also increases. If we are keeping azimuthal quantum number as constant, if n increases, also energy increases. And we can see if n principal quantum number increases, size of the orbit also increases, which means the average distance from the nucleus and the electron also increases. Using n, we can able to calculate energy, right? What is that? What is the formula to calculate energy of an electron? Yes, minus 13.6, right? N square, Z square for any electron in terms of electron. Here Z square indicates, yes, atomic number, Z, N indicates principal quantum number. Then we can able to calculate angular momentum. Angular momentum of any electron in particular orbit or shell, which must be equal to integral multiple of h by 2. So here the n is nothing but principal quantum number. We can able to calculate total number of electrons. Total number of electrons in particular shell using the formula n square. Yes. 2 into n square. We can able to calculate total number of orbitals using n square. Electron in the sense each orbital consists 2 electrons, so we have to multiply with 2. So these are all the major application of principal quantum number. And this principal quantum number starts from 1 till infinity. Right. So the next quantum number here is azimuthal quantum number. The symbol of azimuthal quantum number L. And what are the permissible value of L in the sense? The value restricted by principal quantum number N. So L value can be like 0 to n minus 1. Here, if n is equal to 1, L can be 0. If n is equal to 2, L value can be 0, comma. What is n to? So n minus 1, it is 1, up to 1. If n is equal to 3, the permissible value of L can be 0, 1, 2, up to n minus 1. So the value of L is getting restricted by principal quantum number. Okay, I know the azimuthal quantum number. What is the main significance of this? This is, we can able to say in which subshell electron is located. Right? Principal quantum number gives information about in which shell electron is located. Similarly, azimuthal quantum number gives information about in which subshell electron is located. If L is equal to 0, 1, 2, 3 like that, what is the subshell? It is S, P, D, F. S, P, D, F all called subshells. What is that S represents here? D, P, F represents in the sense from which spectral lines it's arranged. Based on that we can name. In the hydrogen spectral line, this S from short lines and P subshell from principal lines and D from diffuse lines and F is from fundamental lines. Then we are naming it as SPDF. ஒரு hydrogen spectral linesல எந்த lineல இருந்து இதை எடுத்துக்கிட்டோம் அப்படின்றத வச்சு we can name it. And if I know the L value, I can able to say the subshell. Okay, I know the subshell. What is the next in the sense? Each subshell has different shapes, right? Here, S, it is spherical and also symmetrical. Spherical in shape. What about P? It is dumbbell shape. And D, it is double dumbbell. Here, it is a complex structure. So once if I know the L value, I can able to say the shape of the subshell. And we know very well that shell consists subshell. Subshell consists orbital in which the electron is located. And once if I know the L value, what I can calculate in the sense, I can able to calculate angular momentum. Angular momentum of an electron present in particular subshell. Using the formula root of L into L plus 1 H by 2 pi. So L value we can substitute. If it is for S subshell, L value is equal to 0. So the angular momentum of an electron is also 0. Similarly, we can calculate for PDF. So next we can move to magnetic quantum number. So magnetic quantum number represented by M. It gives the information about in which orbital electron is located. Orbital in which electron is located. Okay, so we can assign this M value for all the orbital. First of all, if we are taking S subshell, it consists only one orbital. Right? How to calculate the number of orbital in particular subshell? There is a formula, that is 2L plus 1. Number of orbitals in particular subshell, that is 2L plus 1. L value, if I substitute 0, it will be 1. So S consists only one orbital. P consists 3 orbitals in it. D 5. F it's 7. Right. So now we are going to assign the magnetic quantum number. How can we assign? For S, L is equal to 0. M is also equal to 0. And for P, L is equal to 1. And M can be like 0 plus or minus 1. Right? And for D, L is equal to 2. M can be 0 plus or minus 1 plus or minus 2 up to plus or minus L. And here L is equal to 3. M can be 0 plus or minus 1 plus or minus 2 plus or minus 4. So we are going to assign now. So if it is S subshell, M value is always 0. Here we are assigning the M value. Here for P, it is 0 minus 1 plus 1. Here it is 0 minus 1 plus 1 minus 2 plus 2. Here it is middle one 0, the next one minus 1, minus 2, minus 3, plus 1, plus 2, plus 3. Which means it is up to plus or minus L. Right? So S subshell consists only one orbital. P consists 3. If we are substituting the value using the formula, we will get. So number of electrons in the orbitals. How can we find out if the L value is given? It is 2 into 2L plus 1. Right? That is the another formula. So maximum how many electrons we can fill in the S? It's 2. P subshell we can fill 6. D 5 orbitals are there, so we can able to fill 10 electrons. F we can able to fill 14 electrons. Fine. So this M value is 0 for S. Remember it. Fine. So now, what is the significance of this magnetic quantum number? Since I can exactly say in which orbital electron is located, what is the orientation of it? I can able to say the orientation of electron, spatial orientation, I can able to say, because we are just assigning the p orbital as px, py, P is it. So I have to know in which orbital the electron is located. If I know the magnetic quantum number, I can say it is -1, it is 0, it is +1. Like that, we can be able to see the spatial orientation of the orbitals using magnetic quantum number. Now the last one. Electron spin quantum number. Electron spin quantum number represented by S or sometimes ES or ES. We can represent. So this electron spin quantum number is independent of other three quantum numbers. There are only two values. One is +12, another one is -12. This is +12 and -12 in the sense. Electron will spin its own axis, either through clockwise or anti-clockwise. If two electrons present in one orbital, one will be spinning towards the clockwise direction, another one will be in the anti-clockwise direction. In order to mention that, we are giving this sign plus and minus, opposite. One is the spin up, spin down. Spin up represented by +12, spin down -12. It's all based on the rotation of electron in particular axis. If it is rotating clockwise or anti-clockwise, based on this. If I'm giving clockwise as +12, anti-clockwise will be -12. Or -12 as a clockwise, +12 will be anti-clockwise. It's a relative rotation direction, spinning direction, you can say. So the value can be +12 or -12. It will not be 1, 0, 2 like that, right? Fine. Now we are going to discuss few questions based on this topic. So the first question, what is the angular momentum of electron in P subshell or P orbital? How can we calculate a particular subshell? In the sense, first we have to get the L value. If it is a P subshell, L is equal to 1. What is the formula? If L value is given, the suitable formula here, angular momentum is root of L into L plus 1 H by 2. What is the L value here? It is 1. It is 1 H by 2. So we can say root 2 H by 2. Once we cancel this, we will get H by root 2. So that is a value. Like that, we can able to calculate for D, F kind of thing. Right. Now the next question. If N is equal to 3, what will be the maximum number of orbitals possible? Maximum number of orbitals present. Present in the subshell. So how to calculate it? If we know the principal quantum number, we can able to calculate the total number of orbitals. Yes, that's a formula. N square. So what will be the maximum number of orbitals possible? Yes, of course, it is 9. 9 orbitals possible. How it is possible? If N is equal to 3, what are the possible L values? 0 to N minus 1. So N minus 1, it is 2. So 0, 1. Always the number of L value will be equal to N. If N is equal to 3, 3 values will be there for N. What are they? 3S, 3P, 3D. You know very well that S subshell consists one orbital, P, 3, square. So totally this 9 orbitals are there. What will be the maximum number of electrons? We have to just multiply 2. It is 18 electrons. Arrange the following in the increasing order of energy. Increasing order of energy. So first set here it is 1s, 2s, 3s and 4s. Second set here it is 1s, 2p, 4d, 3p and 3d. Okay, first case if we check, the n value is changing. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. But L is constant. So L here in all these cases it is equal to 0. So if N value increases, energy increases. If we are keeping L as constant. So what will be the correct one? It is 1s will be the lower energy, then 2s, 2p, 3s, 4s. And the next case, we are having S, P, D, all those things. So how we can apply this in the sense? N plus L value, if it is increased, energy increase. So we are going to calculate the N plus L value. What is the N value here? 1. What is the L value? 0 for exception. So it is 1. Here, N is equal to 2, L is equal to 1, it is 3. Here, N is equal to 4, L is equal to 2 for D subshell, it is 6. N is equal to 3, L is equal to 1, so totally it is 12. N is equal to 3, L is equal to 2, it is 5. So we have different F plus L value based on this we are going to arrange. So the least will be 1s, then it will be 2p, then it will be 3p, then 3d, and finally 4. So this is the correct order. If L is constant, we can focus only on N. If N, L all are changing, we have to find out N plus L. In the N plus L also, if the same value we are getting, we have to check only N. If N is increasing, that will be higher in energy. In an orbital, we have to keep 2 electrons. Actually, 2 electrons are there in the orbital. Why we have to assign opposite spin? Why can't we both are spin up or spin down in a sense? Here, just consider if it is 4s2. For the first electron, it is n is equal to 4. For the second electron also n is equal to 4. What about L value? Here yes, so it is 0. Here also it is 0, S subshell. What is the M? For S subshell, it is 0. Here also it is 0. What about the electron spin quantum number? If it is spin up, it will be plus half. Here it is spin down, so minus half. So if suppose if you are keeping both spin up, in the sense what happened, all 4 quantum number will be same for both electrons. So that is wrong. For each electron, the 4 set of quantum numbers should be different, which means maximum 3 values can be same. 4th quantum number will be different, which means in a particular orbital, if 2 electrons is present, both must be present in opposite spin, because if it is present in the same orbital, 3 quantum numbers will be same. Definitely the spin should be different, so that it must be in the opposite spin. What is the rule? It is Pauli's exclusion principle. It says that no 2 electrons in an atom can have identical set of 4 quantum numbers, which means all must have different quantum numbers. So if one electron is present in the same shell, 2 electrons in the sense, n can be same. If it is present in the same subshell, L can be same. Even the same orbital, M can be same. But spin quantum number will differ. So maximum 3 quantum numbers can be same. But 4th quantum number, any one of the 4th quantum number should different. Yes. I hope you understand the concept quantum numbers. You can able to solve more questions in this. Thank you, students.